what I've seen is people want to do more. So people want to do more analytes, more biomarker detection. If they decide to, let's say, to validate up to 10 or maybe even more biomarkers at the same time, it's going to generate a lot of data. I think a lot of people are struggling to basically analyze that data. So the data analysis is one that's going to, I mean, there are some solutions, but I think not everybody, it doesn't fit everybody yet.
I think that the biggest technology impact is going to be bioinformatics. Because you need to be, as multiplexing becomes essential, you need to be switching from individual biomarkers interpretation to index or scoring interpretation, taking into account the contribution of all the biomarkers in the panels. So that's why I think bioinformatics will play an increasing role.
I think the real interest is now building up around liquid biopsy. There's definitely momentum building around that technology now. There's a few different solution providers out there with interesting products, and it's beginning to get traction in the marketplace. More and more people are speaking about it, and there's definite utility there, both in terms of clinical trial assays and also moving into the clinic.
The advancement of low abundance immunoanalytical tools, and there are a range of platforms that are here today, as well as some that are not, that allow for going beyond the type of sensitivity that's achieved with an ELISA platform and focusing far more on very low level sensitivity into femtogram level. So again, these tools that allow us to go after biomarker targets that really weren't possible previously. And I think that's probably one of the areas of technology advancement that's will continue over this year as well as into the future.
I think this next year we're going to see an explosion in the circulating DNA. From the biomarker point of view, it's a wonderful tool that we can use to, number one, screen for patients to put in our clinical trials. We can, two, use it as a monitoring way to figure out if the patient is starting to respond to the therapy that we're giving it through. And the third point is that we can start detecting resistance to the therapy because we can start seeing those mutations appearing in the blood. And with this technology being so sensitive now, with the ability to do blood-based next-generation sequencing, we are going to be able to see those clones coming up earlier and being able to tell the patient then to switch from that medication to a new one. So I think that's going to be the biggest thing this year.